So we will be starting with a POC, that is proof of concept. It will be a mini project and we will be covering this project in 2 days. So let's start with the agenda. The agenda for this POC is Hive usage at Facebook, sample click history data, create table in Hive, static partitioning, dynamic partitioning, mixed partitioning, UDF, which stands for user defined functions, temporary UDF, permanent UDF, use case example, and Hive scripts. So this agenda will be covered in 2 days. The first half will be covering today and the second half will be covering in our next class. So yesterday while introducing Hive, we had a slide in which we were talking about that how much of data is generated over Facebook, and Hive is being extensively used by Facebook to do its business intelligence. So let's start with the first point, Hive usage at Facebook. So when we open Facebook, on the right side of Facebook we can see a different type of advertisements that can be related to some games, it can be related to some online shopping websites, or it can be related to some life insurance policies or any weekend gateways or any other activity. Depending upon like, our dislike, our mood, our interest, we may click on any advertisement. So whenever we click on any advertisement on Facebook, Facebook is capturing our detail. Detail like who is the user, from where he has logged in, what was the date, what was the time, and which type of advertisement he has or she has clicked upon. All these details are captured in a text file, and later on when you have the large amount of data, the big text files are available, we can analyze them. We can process them either using Hadoop or using Hive. So both the technology Hadoop or Hive are using MapReduce framework to process the large amount of data. Because when your data is large, you cannot be dependent upon a single system to process the data. That's why MapReduce is the concept which executes your logic, execute your queries on multiple machines parallelly. And Facebook is extensively using Hadoop and Hive for business intelligence. Facebook is even in partnership with Apache for this technology, that is Hive. So let's move to the next slide and we'll be talking about what are the different fields are captured with every click. So whenever we click on any advertisement, the detail captured are name, day, time, location of user, that is your country, and advertisement category. Actually, Facebook captures so many other things, but since that is a personal user's data, Facebook does not share the data with anyone. So this data which we are talking about, we have generated the test data for learning purpose. So we are assuming that these 5 fields are captured with every click made on any advertisement on Facebook. We have some sample data as well. You can have a look. You can see this. The name of the Facebook user is Sandeep. The day was Friday. The time was 5:30 p.m. The country from where he has logged in is India. And the advertisement category he clicked upon is games. Similarly, we have the next row. The name of the lady is Ekta. The day is Friday, 4:23 a.m. She logged in from Brazil and she had clicked on technology advertisement. And similarly all other rows. Yesterday we created a table employee and we loaded some data into that. I think only 5 rows. But today we are not dealing with 5 rows. Instead, we have 50,000 rows. So as you know, before creating the table in Hive, we always have a look at the data. Once you look at this data, you will realize that we need 5 columns: name, day, time, country, and advertisement category. And if I talk about the data type, the name of the candidate, it should be string. You can correlate with varchar. The day, Monday, Tuesday, Wednesday, again string. Time, 5:30 p.m. Although time is a numeric value, but since it contains semicolon, it contains AM and PM. So to be on safer side, we can make it as string. Then we have the location, the geographic location of the user from where he has logged in, that is your country. And finally, the advertisement category, that is also string. So ultimately all 5 columns as per this data, we can take all the columns as a string only. So let's move to the next slide. Next is create table in Hive. Before we create table, first of all, I will make sure whether my Hadoop is running or not. So I am opening my terminal. I will be moving to local cluster home. Inside that Hadoop, inside that bin, start all.sh. So it will be starting all Hadoop services. After that, we will verify Hadoop services and we will check safe mode status. And once safe mode status is off, that means name node is ready for your service, then only we will be opening our Hive cell. So I can do JPS, secondary name node, job tracker, name node, data node, and task tracker. All 5 services are running perfectly fine. I can check my safe mode status as well. So you can see that in the beginning, because immediately after startup, name node is not ready for your service. It needs some time to collect the required information about all the files, all the blocks, all the duplicate copies, and of course, maintaining the list of live and dead nodes. So once name node will complete all this activity, it will automatically exit safe mode. So let's try once again, and you can see that safe mode is off. That's good. So as you know that in Hive, there is no need to start any service. It's completely dependent upon Hadoop for storage as well as for processing purpose. So what we will do is we will be first of all moving to the bin directory of Hive. Okay, and from here I will type /Hive. That's all. That will be opening my Hive cell. So Hive cell is running, and if you want to clear the screen, Control L. Control L is the shortcut for clearing the screen. Okay, so my Hive is running now, and I'm coming back to PDF. The command for creating the table. Yesterday we had a look at the employee data, and accordingly we created the employee table. Today we had a look at the click history data, and now according to that we will be creating a table. So the command is create table, table name, click underscore history, or you can give some other name, bracket start, user ID string, day string, time string, country string, add category, that is also string, and bracket closed. 5 columns, their meaningful name along with their corresponding data type I have provided, bracket closed, and then row format delimited fields terminated by a tab stored as text file. So this is the command. To save some time, we can simply copy it from PDF and paste into Hive cell. So I am copying this, Control C, coming back to terminal and pasting this. So this command will create the table click underscore history, and then just like yesterday we loaded the data from a local file to Hive table, similarly today also we will do the same. So before we load the data into the table, let's have a look at the data. So there is a file hive underscore POC underscore sample underscore data.txt. This is my file which contains the data for my click history. So I'm opening it just to give you an idea how big it is. You can see that it's taking some time to load because it's a big file. If I will go to the end of the file, you can see this right lower corner ln 50,000 and colon 49. It's telling you that currently the cursor is at 50,000th line and at the 49th column. Ultimately, my point to show this file is that there are 50,000 rows in this file this time. So what we will do is we will be loading the data into the table using the load command which we have used yesterday. So I will be opening my terminal, and before that I would need the complete path and the name of this file. So I am copying the name, and path I can type by myself. So I'm coming back to terminal, load data local in path double quotes slash home slash nearest slash pdf slash hive. Inside that hive POC sample underscore data.txt. This is the complete path of my input file. Now I would say into table name, that is click history, semicolon, enter. So this way your content of the file 50,000 rows will be loaded into click history table. If you want to verify, you can do select start from table, but select start from table will start displaying 50,000 rows here, which does not make any sense, and neither we want that. So while doing select star, if you will give some limit, it will be displaying only those number of rows. So what we can do is select star from click history, and I am giving some limit 10, semicolon, enter. You can see that although your table contains 50,000 rows, but since you limited it to 10 rows, it will be displaying only 10 lines. In case you want more, suppose you want 50, you can make it 50, and accordingly 50 rows from your table will be displayed here. So this is how to create a table in Hive and how to load the data from either local file system or from Hadoop distributed file system, that is HDFS. So after creating the table, the basic operation we have explored yesterday, like executing the query and where clause, executing inbuilt functions, all these things. Today we will be starting with some advanced topics for Hive. So I'm coming back to PDF, and let's see what's next. So we have create table we have done. We have partitioning. Partitioning is a performance tuning technique in Hive. That means it will not change the output. It will change the way it processes the queries. It will change the time taken to execute a query. So we know that behind every Hive table, there is a text file stored in HDFS. You must remember yesterday's class. Behind employee table, there was a employee directory, and which was containing some text file. And the text file is ultimately used as input for the MapReduce queries, or I would say MapReduce job, which are converted from Hive queries. So as a user, you will fire a query on Hive cell. Behind the scene, Hive will convert that query into a MapReduce job. The MapReduce job will be using that file as input data. And finally, it will run the mapper part, reducer part, and final output. But here the challenge is that we need to scan the complete file to find out the result, irrespective of whether we need the complete data or not. For example, out of those 50,000 rows, my query is how many people logged in from India. That means my query does not need the complete data. We don't need the complete 50,000 rows. Basically, I need only India specific data. But here the challenge is that there is no separate file available for India data. We have a single file which contains random data. First row is about India, second row is about US, third row is about Spain, and like that. So if somehow we can store the data in a separate file for different countries, that can make our processing easier. Suppose the number of rows for India is suppose 5,000. If I can get my result just by scanning 5,000, why should I scan 50,000 rows in that case? Here the partitioning concept comes into the picture. So we can use partitioning, which will be increasing the query performance. The reason being is earlier you were dealing with big file, which was containing 50,000 rows. Now if I have a separate file with 5,000 rows for which the country is equal to India, and my job will be using this small file, 5,000 rows file, for processing, it will give the same result, but it will take less time to complete the job. Because you know how MapReduce job runs. Mapper is scanning your input data line by line. That means whether your row is related to India or not, that has to come into Mapper and it has to be checked. Because until or unless Mapper is not checking, how does it know whether this row is related to India or not? So ultimately, all 50,000 rows will be scanned line by line in the Mapper. There are two types of partitioning in Hive. One is static partitioning and another one is dynamic partitioning. What these partitioning are all about, we will be exploring them in more detail and we will be doing them practically. So let's start with static partitioning. So first of all, you have to decide based upon which column you want to create the partition table. I was giving the example of country. That means instead of storing the data into a single file, if we can have separate file for different countries. But that's not mandatory to always partition based upon country. It's up to you. In our table, there is one more column, advertisement category. We can even partition the table based upon that. That means all the rows related to games should be stored in a separate file. All the rows related to other ad category like cosmetic, life insurance, garments, technology, travel. So with every ad category, I want a separate file so that if my query needs the data specific to travel, I don't need to scan 50,000 rows. Rather, I will scan only that file which contains travel related data. So in this example, we are creating a table based upon ad category. So create table, click history part. I have given some name. Bracket start. User ID, that is string, day string, time string, country string, bracket closed. I think we are missing something. We have declared only 4 columns. User ID, day, time and country. Where is the 5th one? 5th is not a simple column. 5th one is a special column that is partitioned by column and we need to declare it separately. So bracket closed and then partitioned by add category, that is also string. Ultimately, there are still 5 columns in my table which contains 4 as simple columns and 5th one, add category, is my special partitioned by column. After that, the same line, row, format, delimited fields. terminated by /t, that is tab, stored as text file. And you can see this. This will create a table with one partition column. Yes, that's true. So let's do one thing. Let's copy the command from here. Control C. And let's paste it into Hive cell. You can see that. Table has been created immediately. I can try show tables. Spelling mistake. You can see that. Click history table is there. That's my simple table. Click history part is there. That's my partition table. Now how to load the data? Because when I was loading the data into my simple table, it was quite easy. I had a text file. I used the load data command and I loaded the data. But here for partition table, as we know, partition table will contain a separate file for games, separate file for garments, separate file for travel, technology, cosmetic. Unfortunately, we do not have separate files available. We have a single file only. In such cases, what we can do is, we can fire a query on my simple table, click history table, with some conditions. I can say that select these columns from this table where add category is equal to games. So out of 50,000 rows, only those rows will come for which add category is equal to games. And that selected data, whatever number of rows, I can insert into one of the partition of the partition table. That means instead of loading the data from a text file, we can get the data from the simple table and we can insert the data into the corresponding partition. So you can have a look at the command and then we will be executing that. The command is insert into table, click history part, partition add category is equal to games. I am telling that I am inserting the data into this table and into this table I will be inserting into the specific partition, that is add category is equal to games. Now let's select the data which we have to insert. Select user ID, day, time, country from click history. That's my simple table where add category is equal to games. This add category is equal to games and this add category is equal to games should be exactly matching. Suppose you are selecting the add category is equal to garments and you are loading it into add category is equal to games. That would be wrong. And Hive will not warn about you. Hive will not issue any error or any warning for that. It's completely your responsibility that you are selecting some specific data and you are loading this data into the correct partition. If you are selecting technology data and loading into cosmetic partition, that's completely your mistake and that would make your result incorrect. Because when your data is loaded into suppose cosmetic partition, your Hive will understand, Hive will consider the data is for cosmetic, but ultimately the data was for technology and by mistake you loaded that into cosmetic partition. So make sure that these two things are exactly same while loading the data into a partition table. So let me copy this command and will be pasting into Hive cell. So I'm copying it, Control C, coming back to terminal and let's paste this. You can see that total MapReduce job is equal to 3, launching job 1 out of 3. As we explored yesterday, that depending upon the complexity of the query, it may be converted into single or multiple MapReduce job. Yesterday, the simple activity we were doing, order by, group by, where close, count function, average function. In those scenarios, queries were converted into a single MapReduce job. But here you can notice that my query has been converted into 3 MapReduce job. These MapReduce job will be running on Hadoop and finally they will give you the result. You can see at the bottom, It is saying okay. That means command has been successfully executed. Time taken 13.655 seconds. It has not displayed any output, and that was not expected, right? The expectation was to insert the data into the partition table, and it has done that. If you want to verify, we can do one thing. I can do select star from click history part, right? I will give some limit 10 semicolon enter. You can see that. And the interesting thing is that advertisement category for all these rows is games. Why? Because till now I have loaded the data only for games. If you want to count the number of rows, we know that all the 50,000 rows cannot be for the same ad category, right? So I want to find out how many rows are there for which ad category is equal to games, which have been recently loaded into our partition table. So I can try select count star from click history part. That's my partition table. Semicolon enter. Spelling mistake from. Okay. So this query has been converted into one MapReduce job. We'll wait for a few seconds. The number of rows, the count will be displayed shortly. So you can see this 8,321. These many rows out of 50,000 rows are containing ad category is equal to games. So now the games related data has been loaded into one of the partition. Let's check it out from the browser, because browser is more convenient way to understand the things. So I will be opening that 50070 page which we opened to access our data from the browser. We'll click on browse the file system. The second last is user. Click on that. Inside that Hive, inside that warehouse, and once I will click on warehouse, you will find the directories same name as your table name. You can see that one directory is click history, another one is click history part, corresponding to the two tables which we have created in our Hive. You can notice one difference, that if I click on the simple directory click history, you will find the file Hive POC sample data.txt which we loaded into the table, and the size is 1.78 MB. So challenge was to process this much of data. For learning purpose, it's quite simple, quite small. Otherwise, when you are really dealing with terabytes and petabytes of data, then we have the production data. And in that scenario, processing the large amount of data means scanning each and every line. Scanning millions or billions of rows is not a good idea. If you will compare the size with the partition table, let me go back. I will click on click history part, and this is the file. Add category is equal to games. Actually, this is a subdirectory. Inside this subdirectory, you will find the file. This one, 000. This is the output of a MapReduce job. That's why internally this name has given. The type is a file, and the size 226.02 KB. Here the point is that if I can get my result just by scanning 226 KB of data, then why do I need to deal with that large amount of data? That's the benefit we are getting from partitioning. Otherwise, you fire a query on simple table, or you fire a query on a partition table, your result will not change. Result will be exactly same. Only difference is the time taken to execute that query. So friends, this is all about static partitioning. So this was about static partitioning, and the limitation, or you can say the drawback of static partitioning is that we have to execute multiple queries. One query I executed for loading the data into games. If I want to load into another partition, I have to execute another query. Let's try that. I will open my terminal and will be loading the data into one more partition. So insert into table, click history part, partition, add category is equal to suppose technology. Okay. Then I will be selecting the column from my simple table with a proper where clause where add category is equal to technology. Okay. And enter. So one query executed for games, one more query for technology, one for travel, one for cosmetic. You may be thinking how many query we will execute. If there are suppose limited number of unique values, as of now in my case, there are I think 6 unique add categories. So 6 commands can be executed. That's not a big deal. But suppose a scenario in which there are 200 distinct values. That means we have to execute 200 queries. That's not a good idea because that's time consuming. That's error prone. It may be possible that you will load the data for a particular partition twice and you may miss any of the particular value of that particular column. It may be possible. For example, you are loading the data for games twice and somehow the data for cosmetic was missed. That's possible. So this is a limitation of static partitioning. To overcome this, we have the another type of partitioning, that is dynamic partition. So I can show you on the web browser. One more directory should have been created. I will go back and I will refresh the page. You can see that. Add category is equal to games, add category is equal to technology. Similarly, you will keep on loading the data into different partition and accordingly subdirectory will keep on creating here. Now we will understand about dynamic partition, because dynamic partition will help you to load the data into all possible partition in one go. No need to execute multiple commands. So I am coming back to PDF and will be moving for the dynamic partition. By default, dynamic partition is disabled. Why? I was telling you that we have to choose the column carefully. I was choosing the column country for partition, that's fine. Because instead of storing the data into single file, if I have 10 countries, that means I can store my data into 10 logical files. That makes sense. Storing 50,000 rows into 6 different files for 6 different add category, that also makes some sense. But let's take some other example. Suppose we have an employee table which has some column employee ID, first name, last name, department, designation, salary. Someone is creating a partition table based upon employee ID. What do you think? Is that a good idea? Absolutely not. Because suppose there are 50,000 rows in your table, employee table, and every row has a unique employee ID, and you have selected that employee ID as a partitioned column. In that case, you know what will happen? Behind your table, there will be a directory. And inside that directory, there will be 50,000 subdirectories. Employee ID is equal to this, first employee ID. Employee ID is equal to second employee ID. Employee ID is equal to third employee ID till 50,000. And every subdirectory will be containing only one file. And that one file will be having only one line for that particular employee. So storing 50,000 rows in 6 files in 10 files makes some sense. But storing 50,000 lines in 50,000 different files definitely does not make any sense. The purpose of using partitioning is to increase the performance, not increasing the overhead of the system. That's why we should choose the column carefully. That column which has the limited number of distinct values, that column can be used for partitioning. Just to avoid these type of scenario, dynamic partitioning is disabled. But that does not mean that you can't use it. If you want to use it, we can enable it and we can use it. There are two properties here, as you can see. Set hive.exec.dynamic.partition is equal to true. The default behavior is that dynamic partition is disabled, but we can enable it. And the second is hive.exec.dynamic.partition.mode is equal to non-strict. When you are using multiple columns for partitioning, I was giving the example of country and add category. You can do that. And while loading the data, you want to use static partition, or you want to use dynamic partition, or you want to mix it. Maybe one column you want to use as static partition and another column you want to use as dynamic partition. In that case, you have to set the second property as well, that is non-strict. That means there is no strictness. It's not like that you have to use only static or only dynamic. If you want to make a combination, if you want to make a mixture of static and dynamic, you can even do that. So I'm copying these two things. Let me copy from the PDF and I will be pasting into my Hive cell. So I will be copying them, and these are temporarily. These properties are set only for that Hive session. That means tomorrow, if you will open Hive session again, you need to enable it again. So I will be copying these two lines and pasting into my Hive cell. Yes. So now my dynamic partitioning is enabled, and now I can come back to PDF and will be executing the command for inserting the data. You can have a look. Insert into table, click history part. That's my partition table. Partition, add category, and I'm not giving any value. If I compare with my previous slide in which I was specifying add category is equal to games, I am not specifying anything in dynamic partition. You can see this partition add category. That means whatever are the distinct values for add category, those values will be automatically considered and will be loaded into the corresponding partitions. And after that, select star from click history without any where clause, because this time I am not selecting any specific data specific to games or garments or travel. I'm not doing that. I am selecting the complete data, and depending upon their add category, first row is about garments, so it will go to garments partition. Second row is about cosmetic, it will go to cosmetic partition. Third row is about technology, so that will go to technology partition. So one command will process all your data, and the data will be loaded into the corresponding partitions. So we can try this. I can copy this command and we can execute this query in Hive cell. So Control C. You can see that total MapReduce job is equal to 3, launching job 1 out of 3. This time we don't need to execute multiple commands. The same query, single query will do everything for you. So let's wait for a few seconds and you can have a look. You can see this. Loading partition add category is equal to technology. Add category is equal to travel, life insurance, cosmetic, garments, games. Data for all possible partition have been loaded into my partition table. You want to verify this? Let me show you from the browser. I will refresh the page and you will find 6 subdirectory here. You can see this. Add category is equal to cosmetic, add category is equal to games, garments, life insurance, technology and travel. Since we have already loaded the data into games earlier using static partition, right? So here you will find duplicate data. You can see that. First file when we loaded into partition table using static partitioning, and the second file copy_1. This is the data when we loaded using dynamic partition. So this way data is duplicate. That's not a good idea. So make sure that when you are loading the data, in case you want to delete the existing data, you can use overwrite command. So let me do one thing. Instead of insert into, I will show you insert overwrite. Let me paste the command here, and instead of into you can write overwrite. Insert overwrite table this one, partition this, select star from click history. So I will copy this command from here and I will be pasting into my Hive cell. So I will paste this command and it will start loading the data into the partition table. So friends, you can see this deleted HDFS colon my Ubuntu 9000 user Hive warehouse. Click history part, inside that add category is equal to travel, games, garments. Why these are deleted? Because we requested for overwriting of data. So initially this data was deleted and after that the new data is loaded, as you can see here. So this time you will get the fresh data inside your all the partitions. If you want, we can go back to the browser and we can verify this. I can refresh this page. You can see that only one file is there. So as per your need, you want to insert more data, maintaining the older data, or you want to delete the existing data and load only new data. As per your need, you can use either insert into table or insert override table. So friends, this is about dynamic partitioning. So the limitation, the drawback of static partition is overcome by dynamic partitioning. Now we have one more type of partitioning, that is mixed partitioning. Actually, there is no such official name like mixed partition. If you will go to Google, if you will search for mixed partition, you may not find anything. Why I have given this name is that we can use static and dynamic in the same query. We can do that. We can make a mixture of that. And that's why I have given the name as mixed partition. You can have a look. Create table, click history part 2. I am creating one more partition table. Bracket start. User ID string, day string, time string, bracket closed. This time I have given only 3 columns as my simple columns. Partition by country, that is string, comma, add category, that is also string. So this time my table is partitioned based upon 2 columns. And after that, row format delimited fields terminated by a tab stored as text file. This will create a table with 2 partitioned columns. Creation is fine. While loading the data, you decide whether you want to use static or you want to use the dynamic or you want to use a mixture of that. Let's have a look. Insert into table, click history part 2, partition, country is equal to India. I am specifying the value. That means it's a static partition. Comma, add category. And I am not giving any value for add category. That means I am using dynamic. So this thing is possible. And after that, select the columns from click history where country is equal to India. Because this condition is there in this partition, I will specify that condition only. Since add category we are using as dynamic, there is no need to specify any condition for add category. So what it will do is, it will be loading the data into all possible partition depending upon the combination of India that is fixed and the unique values of add category. Or if you want to use dynamic for both, you can do that. In that case, simply type partition, country, comma, add category. Select star from table without any where clause. What it will do is, it will create a directory with the same name as your table name. Inside that you will find subdirectories. Country is equal to India, country is equal to US, country is equal to Canada. Inside every country subdirectory, you will find the further subdirectory. Add category is equal to games, add category is equal to garments, travel, like this. In my data, there are 7 distinct countries and 6 distinct add category. So 7 multiplied by 6 is equal to 42. 50,000 rows which are stored in a single file in my simple table. Now those 50,000 rows will be stored in 42 logical files. So if your query is such that you need the data from US for technology, in that case we will be scanning very small file. Out of 42 files, we'll be scanning only one file and will be giving the result quickly. If you will fire the same query on simple table, those 50,000 rows will be processed. So this mixed partition is as an assignment for you. I'm not doing it practically here. You have to do it. In case you will face any issue, I will be here to help you. So friends, with this slide, we are done for the day. We have covered the first half of Hive Facebook POC. The second half we will be covering in tomorrow's class.